All right, guys. Today and the next couple days, we're going to talk about climate. First, a quick definition of climate. Obviously, we talked about this when we started meteorology. Meteorology is day to day stuff. Climate is long term. So we're talking over many, many years, maybe 10, 20, 100-year time periods of measuring the average weather in an area or the average temperature and the average precipitation, which are the major factors that influence climate, measuring those things over a long period of time. Okay, now, obviously, the more observations we have, the longer we've been keeping those observations, the better understanding we have and the better accuracy we'll have about predicting things like climate change in the future. Do we have a good understanding of the climate? Yeah, we do. Is it the best? No, because we haven't been keeping records for very, very long, at least not very good records. So we'll talk about climate science a little bit later on, and we'll talk about stuff like climate change. But the idea is the more accurate we have of a prediction is all based upon how much we've been keeping records, okay, and how long we've been keeping those records. Okay, so on to things that are describing a climate. So a climate can be described by temperature and precipitation amounts. So up here, tropical, temperate, and polar are referring to the temperature. Is it warm? Is it cold? Or is there somewhere in between, kind of like the Goldilocks thing? So is it a large change from season to season? Okay, so that's a temperate climate. We're in a temperate climate in New York State. Humid and arid are referring to the amounts of precipitation that they receive. Arid meaning dry, so low amounts of precipitation, and humid meaning lots of rain. Okay, and we get a lot of precipitation, so we would be considered in New York State a temperate, humid climate. Now, the best way to indicate the climate is just to look at the surroundings, look at the landscape, look at the plants that are in that location. And this is kind of related to some of the biome stuff you may have learned about in biology last year. So if you look at this picture, you'll notice that obviously we have a lot of water here. So that would be a humid climate. Also, you can see it's pretty green. The leaves on these trees are deciduous leaves, which means they drop in the fall. And so in the wintertime, no leaves, and in the summertime, lots of leaves. So this would be described as a temperate climate. So this is a humid temperate climate. In fact, this picture is taken from, I believe, Buttermilk Falls in Ithaca. So it's obviously a pretty close to home picture. Okay, we're used to this. This picture here is what we would describe as an arid climate. The cactus is probably the best indication of that. They live in more dry climates. You can't really tell the temperature here, but I would probably say that's a pretty warm climate. So we would say tropical and arid for this climate. Okay, so the landscape and looking at the vegetation is a really good way to tell the climate. This picture here of the map of North America shows you all the different climates across North America. All these different places are influenced by different geographic features. How close are they to a big body of water like the ocean? How close are they to mountain ranges? Okay, what's the direction of the prevailing winds? Where are the winds coming from across this climate? What's the latitude, right? Florida versus Maine, totally different latitude, totally influences the climate. Okay, so all these different factors that we're about to talk about are going to influence this map. And this is, in some ways, as I just said, very much related to biomes. Okay? All right, so let's start with a very simple one, latitude. Latitude is pretty obvious. The further north you go from the equator, the colder it gets. Why? Because the angle of the sun is going to decrease as you go north. Now, if you think about the equator, the sun is mostly overhead most of the year, like directly overhead. Okay. And that's going to make that climate a lot warmer. Now, if you go up to the North Pole, sometimes the sun's not even out. And often the sun is very low in the sky. Here in New York State, our climate is a little bit cooler, as it described here, right? A cooler temperate climate. Why? Because the angle of the sun is lower than it is at the equator. Okay, so latitude influences the temperature because of the angle of the sun. We'll talk about that a little bit more later on. Latitude also has some role in precipitation amounts. We talked about this with that page in your reference table, but the equator, low pressure, wet climate. Why? Because we have rising air, cooling off, condensing, forming clouds, lots of rain. If you go a little bit over to 30 north, up north from there, the air sinks back down again from that Hadley cell. That sinking dry air leads to high pressure, which means it's sunny, but it's more dry. Okay, so the deserts of the world are located there. All right, so latitude has some role both in temperature and in precipitation amounts, so it's totally influencing climate. Okay, this map here shows you the climates of the world as described by their annual temperatures. The obvious color of orange is a really, really tropical climate, pretty warm all year long. We're in the mid-latitude. Our average temperature in degrees Celsius is around 10, 11 degrees Celsius. And so we're in a more temperate climate, meaning we're ranging throughout the year between, pretty warm and pretty cold. Okay, so it changes rapidly from season to season. Polar climates are pretty much always below 0 Celsius all year long, which means they're freezing all the time. Okay? All right. Other factors that influence climate are geographic, meaning things on land or in the water that influence an area. Elevation is a big one, and this is a pretty obvious one. Obviously, when you go up in altitude, it gets colder. Why? There's less air above your head. We talked about that with the troposphere, right? It's kind of like a blanket. The more air you have above you, the warmer the air stays because it's kind of like trapping that heat. Okay? If you go up in the troposphere, it gets colder. So if you live at a higher elevation, then it's going to be colder. That totally influences stuff around here. There are locations around here that are a little bit higher elevation, and they might get snow, whereas if you're lower in altitude, then it tends to be a little bit warmer. Okay, so elevation is a big factor with this. Now, this is one of my favorites. This is called the effect of a mountain, or the orographic effect on climate. And there's two sides of a mountain, depending upon the prevailing winds. And I'll show you a picture of this in a second. It's what we call the windward side. And maybe I'll draw this on a slide, or I'll draw it on a whiteboard in a second. We have the windward side and the leeward side.
All right, guys, so the orographic effect, I just want to kind of sketch this out for you. So first off, let's just draw a little bit of a landscape. We have the ocean here, and we have a nice mountain coming up over here, and then back down on the other side. Okay, now, as let's say the prevailing wind is going from over here and blowing this direction, okay, off of the ocean, which is over here. Okay, now, as that air comes off of the ocean, it's picking up a lot of moisture. Remember, evaporation puts a lot of water up into the air. So this moisture might not be condensing into clouds. It might just be water vapor that moves in over land here. But as this air blows up into this landscape here, it's going to be forced upward. The altitude is going to increase. So it rises up that mountain. It's forced upward. And in the process of being forced upward, it's cooling off. Okay, it expands. It's under less pressure here. So just a few things to kind of sketch in here. This is called the windward side. Windward is where the wind is coming from. This air is being forced upward, and in the process of doing that, lower pressure is going to cause this air to condense into clouds, and so you're going to get cloud formation over here. And as a result of that cloud formation over here, you're also going to have a whole lot of precipitation happening on this side of the mountain. Okay? So this windward side, very, very rainy climate, and as this air comes back over the other side, all that moisture has kind of dropped out of that air, and therefore it is sinking back down again. And as it sinks back down again, it starts to compress the air molecules, and now we're talking about much drier air over here. So it's wet over here, much humid more humid climate, and this is much drier over here. This is called the leeward side. It's the opposite of the windward side, okay? And the leeward side is much drier climate. So you essentially have kind of a vegetation difference between the two sides of the mountain. Lots of big trees on this side, right? Lots of plants over here, pretty green, nice humid climate.
See there? Look at that. Isn't that a nice little tree? And he lives right here in this brush. All you have to do is sort of push him out. Let's have another one. Maybe he lives right there. Just make a decision and drop him in. Wherever you want him. There he goes. There he goes.
Okay, but on the other side, it's pretty dry. I could try to draw a cactus, but you get the idea. It's a really, really dry climate. Okay, on this side. Little pokey things on my cactus there. Okay, so you get the idea. All right, so windward, leeward, and this is a really, really cool thing to experience. just to see the landscape and the change in the landscape. We'll talk more about that in a second.
So that picture that I was drawing is kind of related to this picture here. I actually took the poster. You might recall there's a poster in my classroom called the Orographic Effect. It's actually right above my head. I took it down, I put it in my room here, and I have it there to remind me that I'm kind of teaching earth science here at home. I feel like I'm in my classroom still. So again, we have the windward side here. The air is rising up that mountain because it's forced upward. That air is going to cool off as it expands. It's called adiabatic cooling. Going to form condensation, cloud formation, lots of rain. Okay, so the windward side is rainy. As the air passes over the mountain and drops back down again on the other side, it's going to dry out because the air is now compressing. Okay, it's forced downward, higher pressure down here. That higher pressure is going to make the air warmer. It's compressing into warmer air. It tends to be pretty sunny. All the rain has kind of dropped out of this. It's like dried out the air. It's like wringing out the sponge on this side. Now it's dry over here. Okay, now, great place where this happens is up in the northwest portion of the United States. As you can see, here's the Pacific Ocean. This is Washington State. This is Oregon down here. We're going into like Montana and this area over here. So if you look, just look at the satellite image, you can see it. These are mountains. This is a mountain range called the Cascade Mountains that go through here. These are the Olympic Mountains right here. And these mountains we're talking like 12,000 feet. So the air is forced up to a higher altitude. It cools off, condenses, forms clouds on this side, and rains like crazy on this side of the mountain. So we have lots of rain in this area of the country. This is actually the city of Seattle right here, and they're a pretty rainy city, as you already probably know. As you pass over the mountain onto this side, the air is now dried out. It's high pressure. It's pretty much sunny all the time, but it's a more dry climate on this side. Okay, and you can see that if you drive the thruway, Route 90, all the way across the country, you'll go right through here, and you go over the mountains, and you come to the other side, and it's like no trees, lots of trees. Okay, no plants, lots of plants. If you go here on this side of the Olympic Mountains, there's actually a rainforest. There's a location here where it rains every day, tons of rain. It's a temperate rainforest, but it is a rainforest. Okay, so again, the windward side, humid, the leeward side, dry. All right, guys, in connection with the whole orographic lifting idea, I wanted to show you this time-lapse image of Cape Town in South Africa. You can see the coastline over here. You can see this mountain range over here called Tabletop Mountain. As the air comes over the mountains, it cools off, condenses, and forms clouds on one side, and up in the mountains, it might be cloudy. But as it comes back down again, it dries out under high pressure, sunny skies over here. And now we're dipping below this line, and the temperature warms up at a certain point, and now all that water that's in the air is not condensing anymore. And so you see these cloud formations right at the top of the clouds. So as I play this, it's a pretty cool thing to watch as that air comes back down over the mountains. It dries out again. Okay, so it's a pretty cool thing to experience and take a time lapse of. This is by far one of my favorite time lapse I've ever seen. It's the same exact thing. You can see the clouds, forming over the mountains and dropping back down. The air is warming up again, but this is great. I mean, look at that. I'll go back to that. This time lapse of the stars going around the sky here. Remember, we're in the southern hemisphere. So if you look at the direction of rotation, let me go back. I'll play it again. Look at the direction of rotation. It's clockwise. Okay, and that tells you it's the southern hemisphere. Polaris, if this was the North Pole, would be right here, but there is nothing there. There is no star in the center there. So a lot of stuff going on here in this great time-lapse image, showing you cloud formation in the mountains, but also a little bit of the stars too. So just wanted to share that with you in connection with our climate stuff. All right, other factors that influence climate are how close are you to a big body of water? Now, we talked about this when we talked about sea breeze and land breeze. Remember, water does not warm up very quickly, and it doesn't cool down very quickly. It kind of stays the same all the time. It has what we call a high specific heat. So if the water stays the same temperature all the time, then the air around that is going to stay the same temperature. It's going to moderate. Moderate means to keep the same, keep even. And so the temperature pretty much stays the same the whole entire year. Okay, so in Oswego, where they're close to Lake Ontario, the temperature stays pretty much the same all the time. It doesn't have big swings in temperature throughout the day. Okay, so that's a major factor there. The prevailing winds. Which way are the winds coming from? Obviously, that influences this, right? If the winds were coming from this side, then this side would be rainy. So the prevailing winds influence this too. In New York, we're getting the air coming across the country from not only like down south and the Pacific Ocean and the Gulf of Mexico, but we're getting stuff from up north from Canada. So the prevailing winds bring all that moisture and all the air from colder and warmer regions, mixes it up and makes it pretty changeable throughout the year. Okay, so the prevailing winds have a major role on climate as well. Ocean currents. We talked about this a little bit, but ocean currents influence climate as well. And if you look at this picture here, remember the Gulf Stream current is a warm current, bringing warm water up north. That water actually goes all the way across the Atlantic Ocean to Great Britain over here, and that influences the climate of Great Britain. We talked about that in the past. California current, cold water coming down south. That brings colder air, and obviously we just talked about this, but Washington State here is kind of cooled off by that as well. All right, so ocean currents have a major role on climate. All right, so this slide here is a really good one. If you want like kind of a summary of everything, just take a screenshot of this picture right here, and you'll see that this all the different factors, latitude, elevation, all that stuff. It tells you its effect on temperature, tells you its effect on precipitation. So that's a nice little kind of summary slide. All right, we're going to look at this. This is what we're going to call the climate of an imaginary continent. And we're going to talk about some questions. I'm going to make you do some questions based upon this image later on as an assignment. So we'll leave that for later. So this is something I used to do in class. I would have kids guess what kind of climate this is. So this is called a climatograph. It shows you the average temperature of a location as well as the average precipitation in a bar graph down below. So this is throughout the year, January, February, March, April, May, as you can see. And in this picture here, if you were to guess what this is, it's a big swing in temperature. It's pretty warm in the summertime and pretty cool in the winter. Gets down to an average temperature of around 20 degrees Fahrenheit in February, January. So where is this? You could take a guess. First thing I'll just say is this is a northern hemisphere climate. How do I know that? Because it's warm in July and June and cold in February and January. So that's definitely northern hemisphere. It's humid because it gets a pretty good amount of precipitation. So where are we? That is Syracuse. Okay, so that's the climate of Syracuse. If you got that right, good job. This one over here, big change in temperature, but look how warm it is. I mean, it's pretty warm all year long. It's above 50 degrees Fahrenheit, gets up to 90 degrees Fahrenheit. So pretty hot in the summertime. Look how much actual rain they get. Okay, so in this location, it's pretty arid, it's pretty dry. So that's a northern hemisphere climate, but it's desert-like because of the lack of precipitation. So where are we? Any guesses? That's Phoenix. Phoenix, Arizona, pretty dry climate. Okay, if you look at this one, lower temperature range, right? It is swinging up in the summertime, but it's cold. I mean, we're talking like the hottest it gets is like an average of about 50 degrees Fahrenheit. So we're probably saying a latitude a little bit further north. In fact, this is a tundra. If you think about biomes, we're talking further north, northern Canada and that kind of location. So where are we? That's Nome, Alaska. If you got that one right, I'm impressed. Okay, but a decent amount of rain, but not a ton. All right, check this one out. The biggest thing that should stand out to you is the fact that look at all this rain. I mean, that's a ridiculous amount of rain. We're talking an average of 14 inches, 15 inches of rain in a month. Okay, that's crazy. Look at the temperature, though. It does not change. It's pretty much always in the upper 70s, for an average temperature. So where is this? Equatorial for sure. We're talking the equator. It's pretty much the same temperature all the time and very, very humid. I think this one's a little bit more obvious, but it's Brazil. That's the Amazon rainforest. Okay, this one here. Now, the biggest thing that should stand out to you is look at the temperature. The temperature is warmer in January and colder in July. that should tell you that that's southern hemisphere. It's a temperate climate. It swings, okay, and they get a pretty decent amount of rain, kind of like us in Syracuse. So where is this? Southern hemisphere. Any guesses? That's Sydney, Australia. Okay. And then finally this one. Now notice the temperature range. We're talking a pretty warm climate, probably pretty tropical. It's getting up to a high, average temperature of 90. We're 100-degree temperatures pretty regularly around, June or so. Look at the rain though. It's a ton of rain for a couple months and then very dry the rest of the time. That is northern hemisphere for sure. Call it a monsoon climate. Lots of rain for only a couple months, dried out. That is India. Okay, so just to give you guys some ideas about climatographs, that should help you a little bit as far as some upcoming assignments that we're going to do together. Okay, so I'll end it there. If you have any questions about anything, let me know. But we'll be talking about this in more details as we go on.